Hello. I'd like to thank the delegates for your interest in watching GeoConvention's Industry Leaders Fireside Chats. I'm Allison Essery, co-chair of the Industry Leaders Session and moderator for this chat on helium. I am happy to introduce the business leader for this topic, David Johnston, who is the CEO of Imperial Helium, a Canadian company. David, thank you for taking time out of your busy schedule to join the chat. I'd like to start with having you give a short bio of yourself for the delegates.
Absolutely. Allison, it's a great pleasure to be here. So my name is David Johnston. I'm a geologist. Came out of the University of Calgary, worked with Shell Canada Resources Limited, went off and did a PhD and wound up with Exxon Production Research, then worked with Husky, with Frontier International here, and sort of did my own startup and worked globally with KOC and Cuffbeck. Came back to Calgary and had an opportunity to start pursuing helium. And so I've been working on helium now for about 4 years.
Thanks, David. Okay, let's begin with you giving an overview of what industries use helium, which is regarded as non-renewable. And can you talk about the concentrations or helium grades that are needed to be economic and for what products?
Right. Helium has a broad spectrum of usage because of its properties. And so it has a diverse use from an industrial perspective. Helium is inert. It doesn't react with anything. So it's used to create pure environments for manufacturing silicone chips, fiber optic cables, high temperature arc welding. NASA, a lot of space applications use it. About 30% of its total usage is in that space. Now, helium also has a unique property that it can be used to create frictionless environments. And as you can imagine, if you can use something to create frictionless environments on Earth that is also pure, that's a unique environment to do experiments. And about 21% of helium is used for research purposes and medical purposes. Then about another 21% is used for cooling. And that's because helium as a commodity has a tremendous thermal capacity. It has the ability to hold heat. It also has the ability to dispel heat very quickly because of the Joule-Thomson effect. That's when gas expands and it cools. So it's very efficient in moving helium away. So MRIs don't exist without helium. It's that simple. The electromagnets produce so much heat, helium works to do that. About 21% gets used for that. Now, helium is one of the two gases we can use to get off the Earth without propulsion, helium and hydrogen. It's the only one that doesn't explode. And then the last thing is that helium is the smallest molecule. It's actually smaller than hydrogen because the nucleus of the molecule has 2 protons and 2 neutrons, so the electrons fly closer. And the end result is it is the smallest molecule. So it's used for leak detection and things where you need the small molecules to find holes. So it's about 12% is used for that. So it has, you can see it has this diverse range of uses. That being said, helium can be economic at very low concentrations. So natural gas somewhere between $2 and $4 for 1,000 cubic feet. Helium in 5.9 grade, which is 99.999% pure. That's mostly for industrial purposes. Somewhere between $400 and $1,000 a cubic feet. So hundreds of times more valuable than natural gas. So economic concentrations sort of in the 1% to 0.5% range.
Great. Okay. And so those of us who had to have MRIs on our knees, thank you for looking at helium. Who are those main buyers? Are these Canadian companies? Who are the buyers where the current helium sold?
Yeah, the major buyers, the helium industry is kind of an interesting place. A little background might be helpful here. So it grew up out of Texas and in Oklahoma, where the major reserves of helium were in the United States. And interestingly enough, it was owned by the US government down the Bureau, and so it was sold through the Bureau of Land Management. And out of that, basically 4 major players emerged. And you know them all: Lind, Praxair, Air Liquide, and Air Products. And they have about 80 to 85% of the global market for helium. That's the global market. So they're the primary buyers and resellers and distributors. There are other companies that are entering the market. Matheson is trying to move in. Awatani is trying to move in. Uniper is moving in as well. And so there are other companies that are moving into this space as well. Those are the major buyers of helium.
Okay, and so can you tell us a little bit more about then the current helium projects that are in Canada and globally?
Yeah, absolutely. So in Canada, this goes back a little bit to price. So I'm going to go sideways for a little bit here, but it figures into the story.
Sure.
Price was pretty stable with the four major competitors until 2013. And in 2013, the U.S. recognized that they were not going to be able to supply helium to the world. So they said by 2018, we'll be pretty much through selling helium. And in 2018, competition entered the marketplace and the price jumped from around $100 to $150. It jumped up to about $337 for 1,000 cubic feet. There was a big increase in price. And after that, the commodity becomes opaque because all the agreements are behind closed doors. So what happened with that big spike was that people in the resource sector recognized that there was a shortage of helium that was coming and that there was a need for more. Now, the US, when they took this gas off the market, took 2.1 billion cubic feet out of a 6.3 billion cubic foot demand space. So roughly a third got knocked off the market. So you can imagine competition really began to go. And prior to that time, Whale down in the Mankota area of southwestern Saskatchewan was probably the only producer in Canada. Since that time, a number of companies have entered and developed the industry inside of Canada. Down along the southern border, Thor is a private company that produces helium, the only producer of helium in Alberta. Avanti is in the land game down there. North American Helium is a large landholder in Saskatchewan, and Royal Helium is out there as well. But there's been increase in the United States as well with a number of companies. You will have heard of Desert Mountain and Blue Star and several other companies. So there's been a big increase in the number of companies looking for helium.
Okay, great. Sorry, and so when we look at those helium projects, are many of them producing it along with the natural gas, or are they producing just pure helium?
Well, the ones down in Saskatchewan and are primarily producing with nitrogen and CO2. Right. But that being said, when you look at the distribution across the province, and part of our strategy, what we're doing is we're looking for helium where it's already been found. So 650,000 wells in Alberta, 189,000 of them have gas analysis, so we know where the distribution is. About 2,000 of those wells have heliums at greater than 0.5%. So we have an idea, and the distribution's all the way across the province, and that makes good sense. Because helium is a product of radioactive decay. Basically, uranium goes to thorium, and when uranium throws out an alpha particle, which is 2 protons and 2 neutrons, it grabs the first 2 electrons that are around it, it becomes helium, it's stable for eternity, and then it migrates up. And as it migrates up, it bumps into hydrocarbons. And so there is quite a bit of helium that is trapped along with hydrocarbons throughout the province. The big challenge is that helium is the smallest molecule, so you have to have an extremely effective seal in order to trap the helium, and that's part of the challenge in finding where it's located. But most of the helium, to answer your question directly, most of the helium in Canada is currently produced with reservoirs that are dominantly nitrogen and CO2 and have some methane associated with them.
Okay, so this is in terms of how this is going to translate to markets going forward. We know that the prices for helium, as you mentioned, were high pre-pandemic, and $300 and upwards to MCF, compared to something like $2 to $4 MCF for natural gas. So, what do you think is going forward now as we get hopefully out of the pandemic? Are we going to sustain those prices? Is that going to continue?
These are really, really interesting times in the helium, because helium is moving from being a North American centric industry with supplying the world to being a global commodity, and there's some issues around it. So other places in the world that produce helium are Algeria and Qatar and Russia, and they're the dominant other suppliers out there. So about 30% of the world's helium comes through the Straits of Hormuz now. There are two major projects. So Exxon partnered with the Qatar National Oil Company in Qatar to sequester helium, and Exxon also partnered with Sonatrach to sequester helium. So they're a big player in this whole picture. Now, when the price jumped up, basically there was a lot of economic rent captured, and you've got an industry dominated by 85%. So my thinking is the price is going to stay high. And the two reasons I have really are, one, economic rent. There's very little reason why those companies would want to give up that economic rent, or the Sonatrach or the Qatar company either. And I think there's very little reason that the Russians would want to flood the market with helium, even with their big Amber gas project, to cause the market to become competitive and lose that price point. So there's not much gain in that. That's one reason why I don't think the price is going to go down. But it's not the largest reason. The largest reason has to do with the nature of helium itself. So helium, in order to be transported efficiently, needs to be transported as a liquid. But it's the very last thing to become a liquid. So it becomes a liquid at minus 272 degrees. That's 1.15 degrees above absolute zero, the place where all molecular motion stops. So you can imagine it's a process, and it's energy intensive to get the helium into liquid form. Then when it's transported in something called an ISO container. And you could go to the Lind website and look this up. They basically look like a sausage inside a sea can frame. And they're transported like sea cans, on container ships. So helium is made into liquid. These containers hold about 1.1 million cubic feet of helium, and then they get onto a container ship. There aren't ships just transporting helium. They're a regular container ship, and then they get shipped. The catch is that there's only a 7-week, 40-day shelf life for those ISO containers before they begin to leak. So helium is on an on-demand product. There's no efficient way to store it in large volumes. So it's not like oil where you can have big tanks of it sitting around. It has to arrive, and that shapes the market. It looks more like liquid natural gas than it does like a bulk commodity. So it's the people down in Australia pay $10 for 1,000 cubic feet of gas because they sell it out of Darwin into China at $10 a cubic feet. We can't get, well, until recently, more than $2 a cubic feet for our gas. Because there's so much gas produced in the United States out of the Permian Basin that it floods the market, and we can't get enough offshore to make our prices rise because we can't transport it and store it efficiently. So you get market localization, and that's what I think we're going to see more driving the price in North America. The US took 2.1 billion cubic feet off the market. We're in Canada, we're selling into that vacuum, and we're close. So the gas could be transported, and it could be transported as a compressed commodity as opposed to a liquid commodity.
That's great. It's as contrary to say some of the oil pipeline problems we have, it seems that having the border that close actually really is a benefit at this point.
It really is. Yep.
Yeah. Okay. So let's talk about then what you think about when you look to see what makes a helium project profitable in Canada as compared to, say, globally. You talked about that a little bit here, but in terms of local people, in terms of, what kind of synergies do they have to have in terms of getting it off the ground and making that work in terms of their infrastructure?
Yeah, helium is explored for much the way we explore for natural gas or for oil and gas. We're just looking for concentrations of helium. So the traditional exploration from a geological perspective is pretty much the same, aside from the identification. When it comes to the facilities are a little bit different. It's not off the shelf. The helium separations. Basically, the way it works is helium is separated on the ground itself, the site itself, and the custody point is at the end of the plant that is on the site. Helium separated through a two-stage process. One's a filter, one is vacuum pressure swing absorption. Vacuum pressure swing absorption. There we go. That takes us to 99.9% pure. Then it gets compressed into tube trailers and hauled away to market. That's how it works. So it can be done, but you have to know how to separate it. It's not quite that simple. the opportunities clearly exist inside Canada to explore for helium. I think we're at the beginning of the development of an industry here in Canada because there is a lot of helium. I've had a map that you can see it even on my website that's out there that shows the distribution of helium across the industry. Those of you that know Alberta will recognize a concentration in the Peace River Arch area, and you'll see another concentration down in the Sweetgrass Arch area. But then when you'll see a shotgun blast across the rest of the province. And what these basically are helium that is migrated through and trapped in all the different traps that you're acquainted with across the basin. The challenge that Alberta will have around this, and those that are rushing to the field to do this, is that you'll find that most of these fields are already depleted. And so the resources are down quite low. So to run the numbers, you know, if you got 10 million cubic feet a day, and you've got 1% helium, then that's 100,000 cubic feet of helium. And at a modest $250 per thousand cubic feet, that's $25,000 a day of revenue, or $9.1 million a year. And you go, fantastic. You know, a separator costs me $4 million. It'll pay off in 6 months and we'll all be rich. Yeah, okay. Now we look at the number of wells out there that are being found at 10 million cubic feet a day, and you'll recognize there aren't many left in Alberta.
Right.
Really, there's a lot of wells that are down at 1%, or sorry, at 1 million cubic feet a day. So a tenth, about the place that we abandon them. Well,
Right.
at a tenth where you abandon them, take the numbers, divide it by a 10, it's about the same thing. So $910,000 a year pays out in 4 years. Not a great business, but it is a workable business. And that's the kind of opportunity that's out there.
Okay. So given that, you know, it sounds like you're going to be competing with capital from, you know, against the traditional Canadian oil and gas investment. How do you see investment right now happening for helium in Canada?
You know, it's been interesting in terms of raising capital in the marketplace, the people that have been interested. The larger interest by far is in the resource community, but not in the oil and gas resource community. The interest has been predominantly in the mineral resource sector that most of the capital funding has been through. That and in funds that are ESG. So we're about 50 at IPO. We were about 50% funds and about 40% retail, and another about 10% management, and so we have been able to attract, because we are ESG. We're friendly to the environment. We have about 3.5% methane, which we'll use as fuel gas. We have about 8% CO2, which will get sequestered, and nitrogen can go into the atmosphere because the atmosphere is 80% helium. So in terms of our project and where we're going right now, that's our approach. Other people coming into the industry will face other challenges around their prospects. If you have something that at the far end of the spectrum, which has hydrogen sulfide and condensates and CO2, then in order to separate the helium out, you have to address all those issues first. You've got to. The helium separator unit basically works on a clean dry gas basis. So you have to put all the money that's associated with that processing system first.
Right. And so some of those projects that are in Saskatchewan, for instance, that are, I think it's like they're 90, 80%, something like that, or 98% nitrogen are a little bit better situated this time because they don't have to worry about some of those nastiness.
That's right. Much simpler. But when you consider the province as a whole and you think about the gas resources in Alberta, a lot of those gas resources are associated with hydrogen sulfide. The hydrogen sulfide is an issue. CO2 is corrosive and is an issue. All those problems have to be dealt with before you can actually get around to processing. So it's not as simple as just let's go do it kind of a deal.
Right.
Yeah.
Okay.
It all has to be worked out.
Right. So if you had to just sort of summarize, you know, what you think are those top three challenges, say, for instance, right now for the helium industry going forward, you know, pricing looks to be okay. What do you think are those top three challenges that you guys and the helium industry in general are facing?
Well, aside from the technical challenges, I think the real challenges that we're facing out there have to do with the fact that helium as an industry is not really recognized yet. And what I say is, okay, on the federal level, helium was defined as a critical resource just this year. But at the CRA level, the taxing level, helium, the technical opinion of the federal government, it's an older one, is that helium is neither a natural gas nor is it a mineral. So it doesn't qualify for CEEs and CDEs. You know, I mean, significant issue. When you consider it at more the provincial level, the province recognized the value of helium and brought in a royalty, and then as Albertan, yay, and as a guy that has to pay the royalty, maybe not so much. But you know, that being said, it is there, but that's as far as it's gone. They haven't recognized the need to help assist the industry in its development, and it is important to Alberta, particularly in these times. That being said, there isn't, from a markets perspective, there is no regulation around helium the way there is for natural gas. So when you talk about resources and you see people quote resources in the helium space, they don't say prospective resource, contingent resource, or reserve, because there is no requirement around NI 5101 or the SEC to define those things. And that's important. It's important to the investment community. So when people talk about resources and having, 20 billion or 14 billion, in resource, it could well be a prospective resource and not a contingent resource, so one should be clear about that from a natural gases perspective. For those of you that are not familiar with the industry as a whole, a prospective resource is an idea that a geologist or a geophysicist has, but it hasn't been drilled yet. A contingent resource is something where you've actually drilled a hole and you have a producible rate, so you know it's there. A reserve requires that you both have the volume, the producible rate, but that you have commerciality established, so you have sales agreements in place. Then it's a reserve, and that's what the banks are interested in, that you can actually sell it and it has value. So that framework isn't set up in the helium space yet, and we need to get that set up so that the investment community as a whole can have a comfort level around who has what, and that these things are real.
Great. So we have about 2 minutes left. Is there a general message that you'd like to leave with our delegates?
I think the general overall message would be is that helium is important. Helium is really important to our future as a whole, and it's important because of its diversity of use inside the market. The number of things that it's used for is not going to decrease. It's expanding, and so the demand is going to go up. It is non-renewable, and it is rare in concentration on the Earth. So we're looking at concentrations of 1% to find economic values. You're not wandering around finding 10 and 20% helium, right? That doesn't happen. So it is a precious resource, and the people that actually use it on for commercial purposes, that there's the anti-balloon market they're all in favor of, because using it for balloons is like, what are you doing? It's so it is critically important to us. Alberta has an important role to play in this. Alberta has a market in front of us, and the Alberta government needs to get serious about the importance of the helium market and the value to all of us, Albertan, as the markets diversify. And we as geoscientists have an important role to play in the exploration for helium and the understanding of it, because at this point in time, the entire helium system is not as understood as you might think it'd be. And Allison, just reflecting on our careers, I was thinking about this the other day, and I was thinking, really, was it only in the 1970s that we thought about source rocks and hydrocarbon systems as a whole? And we didn't really, people were still drilling for deep structures, thinking that oil could come from the Cambrian, and all, even though there were no source rocks deep into the 70s. And and so we're at that kind of level in the helium exploration space.
Excellent. Well, that's our time. I'd like to thank you, David, for taking time out of your day to participate in this conversation. I really appreciate your enthusiasm and ideas for emerging helium development. Thank you again on behalf of GeoConvention for sharing your thoughts today.
It's been a great pleasure, Allison. Thank you so much.